Our basic functions are, there are a couple more, but we'll start with y equals x squared, y equals x cubed, y equals square root of x, y equals cube root of x. We can make an extensive table for a given function and graph a pretty accurate graph, but what we want to do for the purposes of constructing graphs of more complex functions is just get a few basic points that will allow us to graph the function, to construct a reasonable graph of the function. So for y equals x squared, we can construct a reasonable graph if we know that this is a parabola, that this function gives us a parabola, and if we know the basic shape of a parabola. Of course, we would get that by making a more extensive table and graphing a more accurate graph. But having done that, knowing what a parabola looks like, we can just evaluate the function at the points x equals -1, 0, and 1. And what we get is, of course, y is equal to 1, 0, 1. The square of -1 is 1, the square of 0 is 0, the square of 1 is 1. So that if we want to sketch the graph, we plot these 3 points, -1, 1, 0, 0, 1, 1, and we indicate that this is our unit on the x and the y axis, and then we simply sketch a parabola defined by these points with a vertex at the origin. For y equals x cubed, we're going to use a few more points because we want to really get the idea of how this function curves and changes the direction of its curve and so forth, as we'll see. Okay, so if we evaluate the function at -1, we get -1. At 0, we get 0. At 1/2, we get 1/8. At 1, we get 1. And at 2, we get 8. These points and the symmetry properties of the function, which is symmetric with respect to the origin, are sufficient to construct the graph. So let's put 1 about here. Let's put -1 about here. And then 1/2 is going to go here, and 2, of course, will go out here someplace. Okay? So let's just start with the points -1, -1, 0, 0, and 1, 1. If we plot these points, the points are going to be here, here, and here. And for all we know at this stage, the graph is just a straight line through these 3 points. But the graph isn't a straight line. If we then graph the point 2, 8, here's 2. Now 8's going to be way up here someplace, and it's actually up above my labeling, and I'm not sure I'm even high enough there, but it's going to be way up here. So the graph is going to, it's not going to be a straight line. From between here and here, it's got to curve around to get way up here. And of course, we're going to have the point -2, -8. It's actually down lower than this, but I can't draw anything lower than this on the board. Run out of board. Okay, so now we have a point here, a point here, a point here, a point here, and a point here. So how do we draw this graph? Okay, how do we move our way from this point to this point? It's clear that we're going to have to curve this way a little bit, then we're going to have to curve back up. It's not totally clear just exactly how much we got to curve as we go through the origin, but if we graph the point 1/2, 1/8, 1/8 is you divide the interval from 0 to 1 into 8 parts, so 1/8 is going to be down here, and here's 1/2 on the x-axis, so we got a point that's down real close to the x-axis here. And if we use the symmetry property, we're going to have the point symmetric with this through the origin, -1/2, -1/8. You could evaluate that. And we see that the graph comes in very close to the x-axis. And in fact, what's going to happen is the graph is going to curve around and actually become horizontal just for an instant. As it hits the 0 point, then it's going to curve upward, like so. Okay, now that's a behavior that you're expected to know. You should know that you've got to use a point kind of close to 0 here and a point out here someplace in order to get the curvature. Okay, now over here, y equals the square root of x. Now, x can't be negative. Okay, the square root is not defined for negative x, so that we could use the x equals 0 point. The square root of 0 is 0, and the square root of 1 is 1. That doesn't give us an abundance of information about the graph. Here's 1 on the y-axis. We have the point 0, 0 and the point 1, 1. For all we know, it's a straight line. Or maybe it curves upward like this, or maybe it curves like this. We don't know. So we go out to some later number. Now we could do 2, but do you know what the square root of 2 is? You should. It's 1.414 to 3 significant figures. You should know that, but you might not. We could use 3. The square root of 3 is about 1.732, but you probably don't know that. We could go to 4. The square root of 4 is 2. Well, that's nice and neat, so that's why we use 4. We know what the square root of 4 is. It's 2. We come out here 3 more units, and come up 1 more unit here, and project over and up, and we get this point. And we see that the graph looks something like this. Now, there are other characteristics of the graph. We don't know exactly how steep it is at the origin. It turns out that it starts out pretty much parallel to the y-axis and then quickly turns like so. The other thing I'll say is this curve here is basically identical to half of this parabola. If we take this half and flip it over and invert it, we get this graph. So this is just really the shape of this. If we were to rotate this curve this way, we would get the negative part of the y equals x squared graph, the part to the left of the y-axis, and then reflect that to the right, so that the shape of this curve and the shape of this curve are in fact identical. Okay, cube root function. Now I haven't written any numbers down here because I want to motivate these numbers. The cube root is just inverse to the cube, in the sense that if we write down these y numbers and take their cube roots, we're going to get these x numbers, because the cube root is, again, just the inverse of the cubing function. So if we write the y numbers in the first line, -1, 0, 1/8, 1, and 8, if we take the cube roots of these numbers, the cube root of -1 is -1 because -1 cubed is -1. Cube root of 0 is 0 because the cube of 0 is 0. The cube root of 1/8 is 1/2 because the cube of 1/2 is 1/8. The cube root of 1 is 1. The cube root of 8 is 2. Again, because the cube of 2 is 8. That's the meaning of the cube root operation. If we graph this function, we can set our unit points here, 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 and here on the x-axis. We have -1, -1. Of course, that's a point on the x cubed graph as well. And we have the point 1, 1 and the point 0, 0. Just like before, with these 3 points, for all we know, the graph is going to be a straight line. But now, 1/8 gives us 1/2. That means when x is 1/8, y is 1/2. Well, 1/8, we divide the interval from 0 to 1 into 8-bit parts, and 1/8 is really close to the origin. And 1/2 is half of a unit, so we have a point here. It's close to the y-axis, but up a ways. And we see that the graph here is going to have a curvature, getting in my own way here, have a curvature that goes something like this. The symmetry tells us that the negative 1/2, negative 1/8 point, negative 1/8, negative 1/2 point is also on the graph. And then we have the point 8.2. Now 8 is way out here. Maybe it's about here. 2 would be up here, so that negative 8.2 may be here. And we have negative 8, negative 2, too far over here to graph. But if I graph this part of the curve, maybe 2's up a little higher there, okay, then the symmetry tells us, symmetry with respect to the origin tells us that we're going to get just the opposite down here, and there's the graph of y equals cube root of x. There are at least two other basic functions in addition to the trivial one, y equals x, and I'm not going to illustrate that. That one's really easy to graph. You need to know this. You should be able to do this. You should be able to construct this whole thing in about 2 minutes with just this limited series of points and get an idea, a good idea of the shape of each of these graphs.